Hello, Mrs. Pierce here. Alright, so now that hopefully you know how to solve equations, let's get some more practice writing equations. Okay, so before we actually write equations, let's just do a little review on rearranging equations into y form, just for fun. So this says rearrange the following equations into y equals mx plus b form. That is actually the slope-intercept form. And then state the slope and the y-intercepts. Okay, so for the first one, we need to get this 3y by itself first. So that means I need to do something with this 21. And so I'm going to subtract 21 from both sides. Notice I did not write the 21 under the 9x, since they're not like terms. That way, hopefully, I will remember not to combine them. And then I've got 3y equals 9x minus 21. Okay, so now I've got this 3 here, and I need to divide both sides by 3 to get y by itself. So now I'm going to divide by 3, divide by 3, divide by 3. That is going to leave me with, let me move this down here a little bit. Okay, that's going to leave me with just y, which is what I want. Woohoo! And then 9 divided by 3 is 3x. 21 divided by 3 is 7. So my slope, remember the slope is the coefficient of x, not x, just a coefficient, and my y-intercept is this number without a variable. So my slope is 3, and my y-intercept is negative 7. Awesome. Okay, let's go to the next one. So again, I need to somehow get rid of this 3x because I want the negative 4y by itself. So I'm going to subtract 3x from both sides. I am not going to line up the 3x with 12 because they're not like terms. That's going to leave me with negative 4y. Be careful, that's where a lot of you mess up because you forget about that negative. And then I'm going to write, I'm going to put that negative 3x first so that x is first. And then the 12 is positive, so it's going to stay positive. And then last, I've got to divide by 4. Actually, I'm dividing by negative 4. So I'm dividing every single thing by negative 4. Moving this down a little bit. Woo! I didn't mean to do that. That's what I meant to do. Actually, that's not what I meant to do. But we'll leave it because it's just funny. Alright, so when I divided everything by negative 4, I end up with y. Now here's the deal. Do you see these guys? 4 does not go into 3. So I'm going to leave it like a fraction. But then also we have two negatives. Guys, negative divided by negative is positive. So negative 3 divided by negative 4, I'm going to leave it as 3/4. I've got my x there. And then 12 divided by negative 4 is negative 3. So my slope for this one is 3/4. It's a fraction. And my y-intercept is negative 3. Now if you had said, if you divide and got 0.75, that's okay too. So, alright, awesome. Now let's start solving some equations. Alright, so I kind of gave you the variables that I wanted you to use, but I want you to get practice writing let statements. A let statement just tells me what the variables stand for. I mean, now that we've got words, we can't just have letters without meanings to them. So it says, Mrs. Pierce, that's me, is P years old, so P for Pierce. Her mom is M, we'll say M for mom, is 73, less than 3 times Mrs. Pierce's age. Write an equation for her mom, that should say. Sorry about that. Alright, so first of all, let M stand for mom. So let M stand for the mom's age. And we're going to let P stand for Mrs. Pierce's age. And that's it. We don't have to solve, like when I say let M equal, that doesn't mean the answer. That just means tell me what the M in my variable or in my equation is going to stand for. Okay, so writing an equation for her mom, well, then I'm going to say M equals, and if I go through here, it says her mom is 73 less than. Here's the deal, guys. When it says less than here, it means I'm subtracting 73 from something. Be careful, I don't start with 73. I am subtracting 73 from something, so I'm going to write a minus 73 down here. Now what am I subtracting it from? I am subtracting it from 3 times Mrs. Pierce's age. Make sure you finish the whole sentence. So that means 3 times Mrs. Pierce's age, oops, P for Pierce, see, that's why we need to know what our variables stand for. 3 times Mrs. Pierce's age minus 73. And that is it. There's my equation. Done. Let's go to the next. Okay, this one says the number of boys who are playing in hoops for heart is 10 more than twice the number of girls. Okay, so my let statements, I wonder what I want B to stand for. Let's let B equal the number of boys. And let's let G equal the number of girls. That's all we need for the let statements. Okay, tells us what the variables are going to represent. And then for my equation, it says boys are, the number of boys is 10 more than twice the number of girls. Okay, the is usually our equal sign in math. Okay, so I've got the number of boys is 10 more than is adding twice is 2 times the number of girls. And that's it. That's my equation. Okay? Alright, let's try another. Okay. This one, I've got 2 in the same one. It says, an adult ticket to the movies is $9.50. Actually, true story. I just went to the movies this weekend, and it really did cost me $9.50, because I'm an adult. Alright, and a child's ticket costs $4.75. I'm going to change that, because it actually should have been a 5 there. Sorry about that. If $6,531.25 was collected, write an equation to represent this information. So I am going to let A stand for the number of adult tickets. And I'm going to let C stand for the number of child tickets. Okay? Alright, and then for my equation, well, it's $9.50 for every adult ticket. So $9.50 times the number of adult tickets. And plus $4.75 times the number of child tickets. That all has to equal $6,531.25. So there's my equation. Again, if I was the cashier and I took in all the money for one movie for one particular time, it would be $9.50 times the number of adults, and then $4.75 times the number of children's, and we know that they collected $6,531.25. Okay, using that same situation, so I'm still going to let A equal the number of adult tickets and C equal the number of child tickets. Now we have to write one for this information. So if the number of child's tickets was 25 less than, look, there's that less than again, so I'm going to do minus 25. So it was the number of child's was, okay, so this was is like your equal sign there, 25 less than twice the number of adults. So there is that equation. Alright, so now going on to the next slide, we're going to have to take those 2 equations and we're going to have to actually solve them, because now we actually have 2 equations with 2 variables, so I can actually solve for my 2 answers. Okay, so I copied my 2 equations from the other side, so I've got 2 equations, 2 variables, so now I can actually solve it. Okay, so now I need to figure out how am I going to solve it. Well, I can't use the equal values method, because look, I have C by itself, but in the other equation, I don't. I can use substitution. So notice all this stuff here is the same as C. So what I'm going to do, I'm going to take this stuff and I'm going to replace it with C up there. So let me rewrite that. So now I'm going to rewrite the first equation, 9.50a plus 4.75. Now instead of C, I'm going to write all that stuff that C equals. C equals 2a minus 25. And then that has to be $6,531.25. So notice the only thing that happened is this stuff right here used to be C. So instead of C, I replaced it with what C was actually equal to. And now we just got to start solving. So I'm going to have to use the distributive property here to multiply those guys. I'm just going to use different colors because it's fun. And 9.50 is the same as 9.5, so I'm just going to leave that as 9.5a plus 4. I cannot even write. 4.75 times 2 is 9.5a minus 4.75 times 25 is 118.75, and all that again should equal $6,531.25. Okay, notice here I can combine like terms. Okay, those are on the same side, so I can just add them together. And when I add them together, I get 19a minus 118.75. All that equals $6,531.25. I'm going to add $118.75 to both sides. And when I do that, we get 19a equals 6,650. I'm going to divide both sides by 19. And I get A equals 350. Look at that. Turned out pretty nice. Let me... there's my answer. Except I had two equations. And so if I have two equations and two variables, I need two answers. So if I know now that 350 adult tickets were sold, well, I'm just going to go up here. I'm going to go up here. So the child's, it says, was 25 less than twice the number of adults. So if there was 350 adults, I have to find twice that, which is going to be 700 minus 25. So that means that the children's were 675. And so there are my two answers. Sorry that this is so sloppy. Hopefully you get the idea. Okay? All right. Awesome. I'm out.